Chapter 5 is going to be on polynomials, and in 5.1, we're going to talk about the graphing of polynomials. So in the last chapter with quadratics, we were obviously dealing with stuff that's x squared. Now we're going to go with higher degree functions of how to graph those. So there's going to be a couple of differences, some similarities. We're going to start off by doing the quadratics and then seeing how that relates to what would come up with higher degree functions after that. So this particular one here, I'm going to graph at the end, but this is what we're leading to of how do you deal with all of these with the high exponents that you'd have, and this one would have a degree of 9 on it when you would do it. So how would you go about graphing those type of things is what we're leading to. So I'm going to do this example here at the end. So in order to do the graphing of polynomials, we're going to need to have it in factored form. When you have your higher degree polynomials, you're not going to be able to just look at something that's an x to the 6th and probably graph it, if it's got a bunch of stuff after it. So we're going to take our expanded form, which we had as standard form in the previous chapter, and we're going to factor it. Now, some of those are going to be easy to factor, some of them are not, and that's what the middle part of the chapter will be, is how do you come up with those factors to be able to graph it. So let's relate what we did here. Let's go through what we did with quadratics real quick. So in your quadratics, one of the ways that you could do it is to factor it. So that's what I did here, x minus 6, x minus 1. So you'd have x-intercepts at 1 and at 6. Positive leading coefficient, so your graph would open upward. Now, when you do a polynomial, you're not going to have a vertex because you're going to have maximums and minimums throughout the graph is what you'll have. So I'm not going to talk about, go through why your vertex is in this spot right here. Just knowing that it opens upward through these x-intercepts is what I'm going to concentrate on today. All right, x-intercepts at negative 1/5 and positive 1. Negative leading coefficient, so therefore your graph opens downwards. And your x-intercepts at positive negative 3/2. Positive leading coefficient, therefore your graph opens up. So what do you take that into cubics? How would that work? So like I told you here a few minutes ago, it needs to be in factored form. So most of the time I'm going to have it factored for you right now, but this one's easy enough to factor. So you factor out what it has in common, and then the x squared minus 1 will factor at x minus 1, x plus 1. So you're going to get x-intercepts at 0, at 1, and at negative 1. All right, if I was just graphing plain old y is equal to x to the 3rd, that would be a quick sketch of the graph. So the ends start down here, end up here with a positive leading coefficient. So I'm going to kind of use that idea here as well. So I'm going to start down here, go through that x-intercept, change direction somewhere, come back through this one, change directions, go back up. Okay, same end behavior that we had for this one over here. Now, what is this value here and what is this value here? That's for another day. What I'm going to concentrate on with this is the ends, the x-intercepts, and y-intercepts. That's what we'll be looking at here today. Okay, this one that's already graphed for you. Let's move that over to the side. Okay, we've already got the factors in this, so you'd have x is equal to 3/8, negative 4, and 7. Okay, let's put 7 out there. Let's put 4, negative 4 right there. And if this was a 1, 3/8 would be somewhere around there. Okay. All right, y-intercept on this one, if I plug in 0, I would have negative 3 times 4 times negative 7. So that's going to be positive 84. So I'm going to put that there. Again, don't draw 84 dashes. We're just getting a general idea of what this looks like. Positive leading coefficient, I got positive 8x, x, and x. So I would have a if I were to multiply it out, I would have 8x cubed, so positive 8x cubed. So I'm going to start from down here, work my way up, come back down, go through the 84, go through this, come through the 7, and you've got your graph. Okay. Now, why did I go above the 84 here? Why didn't I just go straight from the -4 to the 84, change directions there, come down? Well, think about that. That doesn't really make any sense. It's going to have to come above and come down here just because of the spacing from the -4 to the positive 3/8. And on the calculator, it would look like this. See how the values here I needed to make fairly large to be able to get this value in down here. So again, what is this value here? Something we would get from the calculator. But for now, skipping that. All right, on this one, x-intercepts at, let's move this away. Oops. X-intercepts at 4, at -1, and at positive 7/2. Let's move that further over. One, 4, 5. There's my 7/2. There's my 4. There's my -1. If I multiply these out, so plug in 0 for the x's, I would have 4 times 1 times -7. So that would be at -28. And then this one, the leading coefficient would be negative because I would have -x times 2. So I would have -2x cubed. So that means I'm going to have to flip the graph. So it's going to start here instead. So I'm going to come down, go through my -28, change directions, go through the 4, change directions, go through the 7/2. 7/2, not 6/2, not 9/2, sorry. I need to scoot this over. Let's make this like this 3, make that 4. Sorry about that. There's the 7/2. I did that as 9/2 on accident. Sorry about that. Right, that'll be your value there. Okay. All right, that's cubics. What about larger degreed ones? So 4th degree on this one. So 7, -1/2, 8, and 9. All right, so 7, 8, 9, -1 there. So there's the -1/2, 7, 8, 9. So if I would have y is equal to x to the 4th, because that's what this would be if you multiply x, 2x, x, and x together, that graph goes like this. So positive leading coefficient, end behavior would be up on both of them. If it was a negative leading coefficient, it would go downwards instead. All right, so on this graph here, y-intercept. So at a y-intercept, we would have -7 times 1 times 8 times 9. If I multiply that out, times -8 times -9, excuse me, those should be negatives. So I'm pulling up the calculator. I forgot to multiply it together before. Bear with me for 1 second here. So it's 504. So -504. Okay, so this graph will start up here, go through this point, go through the negative 504, change directions, come through the 7, come through the 8, go through the 9, and there would be your graph. Okay, and this is what it would look like. So because this goes down so far, you can't really see it very well here, and that's going to be the problem with the calculators. Being able to tell what's going on right here is sometimes that's going to be too hard to do. Okay, so now we're going to introduce another part here. What if something is not to the first power like all of the previous factors have been? What if you have squared or cubed or fourth? So let's do one that's got a squared on here. All right, so again, this is a fourth degree polynomial. Negative x times x times x would give you, times x squared would give you negative x to the fourth. So our zeros on this would be at 5, at negative 2, and at positive 6. We would have a y-intercept. So for our y-intercept, we would plug in 0 for the x's. So we would have 5 times 2 times negative 6 squared. So if I multiply those together, you will get 360. Okay, and negative leading coefficient means we're going to start down here and we're going to end down here. Now the difference on this one this time, when you have a squared, it's going to bounce at the x-axis on that spot. Think about if you were to graph y is equal to x minus 4 squared, that graph did this here at 4. So it bounces at that spot. So when you have an even exponent, it's going to bounce at that spot. When you have odd exponents, it's going to go through. So everything we've done up to this point has always been odd exponents, so that's why I've gone through each time. So I'll expand upon that idea here as we move through. So we are going to start down here, negative leading coefficient, go through the 2, come up through the 360, change directions, go through the 5, change directions. At the 6, you're going to bounce. And you have a graph that looks like that. This didn't turn out very good here. There we go. It's a little better. Okay, so negative leading coefficient, both open, and fourth degree, so both will open in the downward direction. Start down here, go through your y-intercept, and then bounce at the 6. All right, so for a 10th degree. So I'm not going to, the y-intercept on this one's going to be absolutely huge, so I'm not going to even worry about the y-intercept on this one, but just to demonstrate what's going to happen with these exponents here. So you have a 10th degree because you've got 4 here, 3 here, so that's 7, 2 more here, that's 9, 1 here, that would be 10, so 10th degree. So your x-intercepts in this would be 5, 1, negative 2, and positive 8. And we would end up with a negative leading coefficient because you'd have negative x to the first times x squared times x cubed times x to the fourth, so you'd have negative x to the 10th. So again, with even degrees, my end behavior, both of those will be down here. So I'll start down here and I should end here. On this one, because it's to the first, that's being an odd number, it's going to go through. This one being even, it's going to bounce. This one being odd, it will go through. And this one being even, it'll bounce. Okay, so at the negative 2, the first one there, I'm going to have to go through that one. At the 1, I'm going to bounce. At the 5, I'm going to go through. And at the 8, I'm going to bounce. All right, so I'm going to start down here. come up, come back down. At the 1, I'm going to bounce, change directions. At the 5, I am going to go through, change directions. At the 8, I'm going to bounce. And again, the y-intercept would be whatever 5 times 1, negative 1 squared times 2 cubed times negative 8 to the 4th would be a very large number, as you'll see from when I pull this graph over, what I had to do my y-scale as. Normally I'd find the number, but it's too big of a number to worry about here. More concerning is what's happening here at each one of the x-intercepts and having the end behavior like it's supposed to. All right, so let's do our original problem here. So x-intercepts at 3, at negative 4, and at positive 5. At 3, I'm going to go through because of the cube. At 4, I'm going to bounce because of the squared. And at the 5, I'm going to bounce. All right, and our y-intercept, let's find this one here. So we're going to have 3 cubed times 4 squared times negative 5 to the 4th. So when I multiply that out, so 3 cubed times 4 squared, so 16 times negative 5 to the 4th would be 270,000. Okay, so let's put our numbers here. So we got negative 4 there, 3 here, 5 here, 270,000, excuse me. And we are going to have a degree on this one of 9. 3, 2, and 4 would give me 9, and a negative leading coefficient. So my graph is going to start up here. It's going to end down here. So I start here at the 4, I bounce, come up, go through there. At the 3, I'm going to pass through, and at the 5, I'm going to bounce. There's your graph. So that is how you do graphing of your polynomials. Let me know if you have any questions.